Today we're going to look at two rules for differentiation. The first of these is the product rule. Now a product is where you've got two functions multiplied together. Each of them is a function of x. We call these u and v. So here in this example, e to the x is u and sine x is v. Or we could have labelled them the other way around, since it doesn't matter which way you multiply them. Here in this second example, we've got y equals x cubed times 1 plus x to the 4, so that's my u and v. And the third example, y equals log x times cos 4x. So let's see the product rule in action. Here it is. If y equals u times v, then dy dx is v du dx plus u dv dx. So we've got four things that we need to put in on the other side. So starting with y equals e to the x sine x, let's find dy dx. On the left-hand side, I've written down the formula. On the right-hand side, I've got my working section. So u is e to the x, v equals sine x. Underneath u, I've differentiated to get e to the x, and underneath v, I've differentiated to get cos x. Putting them into the formula, I get v du dx plus u dv dx, and that can be made to look nicer by factorising out the e to the x. Here's a second example. If y equals x cubed 1 plus x to the 4, again let's find dy dx. So u equals x cubed, v equals 1 plus x to the 4, and on differentiation du dx is 3x squared, and dv dx by the chain rule is 4, 1 plus x cubed, and multiplying by the derivative of the bracket is 1, so I haven't written that, but I have applied the chain rule. Putting those into the formula, I've got v du dx. Now notice, instead of writing a times, which might look like an x, I've written a dot, and that's alternative notation for multiplication, plus u times dv dx. Tidying that up a bit, I factorised out the x squared and the 1 plus x cubed and put everything else in a bracket. You might want to take a moment that if I were to multiply that by the first term and that by the second term, that it would actually get back to the line before. Tidying up the bracket then, I get x squared, 1 plus x cubed, and 3 plus 7x. Pause the video and try this one, and then check your answer with the solution that follows. So y equals log x cos 4x, find dy dx. Here's the solution that you should have got. If you didn't get it, just work through it carefully now and try again. The second rule we're going to look at is the quotient rule. Now quotient here, we're talking about a fraction, so a function over a function. So if it looks like y equals u over v, where u and v are both functions of x, then the rule is dy dx equals v du dx minus u dv dx, all over v squared. Here's a couple of examples where we've got u over v. Looking at the first one, again, we need four things: u, v, du dx, and dv dx. On the left-hand side, I've written the rule so that I make sure I put them in the right place. And on the right-hand side, u equals e to the 2x, v equals cos x. And then I differentiated each of them. E to the 2x differentiates to 2e to the 2x by the chain rule, or by standards. V equals cos x differentiates to minus sine x. Now putting all of those things into the right place, so v du dx minus u dv dx, all over v squared. And notice we write cos x all squared as cos squared x. Making that look pretty, we've got a common factor of e to the 2x, and don't forget this minus times a minus makes a plus. Have a go at this one, pause the video, and then see if you get the same answer as on here. So my choice of U and V are those. Differentiated, fairly straightforward ones. Put into the quotient rule, so V du dx minus U dv dx all over v squared, and now we need to make it look pretty. So multiplying out the top for both pieces, and then simplifying.